Welcome to another Python video. We're going to be doing a string palindrome checker function. We're going to write a function that returns true if the given string argument is a palindrome. Palindrome is a word that is spelled forwards and backwards the same. So I have an example of taco capping a palindrome, because if you were to spell that word from left to right or right to left, it will still give you the same word. Whereas a taco dog is not a palindrome, because if you were to spell that backwards, you would get gato cat instead of a taco cat. Okay, so we're allowed to assume that our argument is going to be only containing alphabetical characters, and we're actually going to do two solutions, and we're really going to analyze and practice string indexing or list indexing in this. Well, you can use it as list indexing as well, but basically anything that supports indexing in Python will follow the same structure, so we'll be practicing it with a string. Solution one, I'm going to be explaining this lovely slicing mechanic called I guess the slice, I'll make it I guess reversed. Okay, so just a quick note: if variable a is hello, just quickly, I just wanted to recall that if variable a is hello, okay, we can say that we'll index and grab single characters. If I were to look at a at location 2, it's going to grab this value right here because it's located right here, right? Looking at hello, 0 is H, 1 is E, 2 is L, 3 is L, 4 is O, 5 is exclamation mark, okay? And I always want you to remember that it's always, the numbers are always on the left side. It starts right on the left, okay? Okay. So, well, if indexing grabs single characters, there is a concept called slicing where you can actually set up a range, much like a range function, but it helps us grab certain areas of a string, list, or any item that is indexable. So in this case, we're going to be starting at 1 and going up to, but not including 5. So notice how I'm starting at 1, containing everything, and going up to, but not including 5, just like how a range would work. That's how we get the characters of E, L, L, O, because we started at 1, I'm grabbing all of these values right here and not including 5, so that gets me a low. Okay, so well, what is this then? It is now a slicing. If you notice, there is no start and end value, like whereas this one had a start and end value. So the cool thing about this is that if there is no given start or end value, it's going to be assumed as implicit. It just means that you're going to look at this holistically. But after the first colon, you could put a second colon in to say that, well, I want the intervals between each characters when I'm slicing to be following this value, just like the step counter in a range function. And this one, we're actually saying it's going to be -1. So instead of going this way, where we start from 0 and go include all our values, we're going to be looking at it holistically, but we're actually going to be going on a negative pathway. Okay, so we would actually start from here and go all the way to the end like so. Okay, and include all of that, but in reverse. So the very first character of this will be exclamation mark, then O, L, L, E, and H, so that if I were to do a reverse slice of A, which is like that, that's going to give me exclamation mark, O, L, L, E, H, like that. Okay, so it's going to completely start from 0 and just flip everything around until it gets to the very end where we are analyzing the string holistically. So if I were to write a function that does this, it is very simple. We're going to say def we'll call it is palindrome 1, because we're going to write a second solution in the bottom, and we're going to be given some text. And we can say that, well, we can return our current text compared by the reverse version, and if they're equal, we have a palindrome. Okay. So we can say that checks if our given argument is a palindrome. So argument, we're going to have text, a string, alphabetical, an alpha-based, alphabetical-based string. We're going to return a Boolean value, true if the text is a palindrome, false otherwise. end of is palindrome 1, like that. Okay, so it's a very simple one-line function where we take our current text and we compare it to the newly generated, the reverse version of our text by using our slicing mechanic, where we're looking at a string holistically by looking at it in a negative way. So we're kind of flipping it. So starting from this value first, and we're going to include everything all the way into the end because we're looking at it holistically thanks to the implicit start and end. All right, so we get exclamation mark OLLEH. Well, if the reverse of the original text are equal to each other, we're now safely allowed to say that we have a palindrome. Okay. Another way that you can do this is, well, we can determine the midpoint and then check to see if the other end is the same. All right, so this one's going to take a little more code, but it might make more sense to you to do it this way. Therefore, I'm going to write the solution. I'm going to call it 2 text. All right, we're going to have the same documentation, so I'm just going to copy that over like so. Okay, we're going to have this text. Well, we're going to have to do some checks first. We're going to say, well, if not text, right? Text is an empty string. Well, in that case, we can just return true. Like empty strings should be palindromes. We can say elif length of text is less than 4. Right? Then we can just say the return. The text at location 0 should equal text at -1. For strings with length of 1, 2, 3, as long as the first and the last characters are the same, it is a palindrome. Right. So there we go. Now we're going to get into the territory. Well, else, right? We're going to be now looking at text that has a length greater than 4 or equal to 4. Our text is now guaranteed to be length of 4 or greater. Alrighty. So here we go. So we have wrote some if statements. I call these like base cases, like the simplistic version of our test, so that we can get these right away. And then we only do our complicated calculation only if we reach a certain scenario. Okay. So now let's find a midpoint. Right. Midpoint of our string is going to be found at, well, length of our text divided by 2. And our rules are going to be the following. If the length is odd, we get to ignore middlemost character. All right, so let's examine hello. Right. It's at location 1, 2, 3, 4, 5. Sorry, these are our location, has a length of 5. Right? I only need to compare 0 and the 4th one, and the 1 and the 3rd one. As long as, well, there's the middle character has nothing to compare. Right? So we can just leave it as it is. Whereas, you know, if we had 3, a length of 4, or any even number string, like hell, well, I need to compare the 0th and the 3rd character and the 1st and the 2nd character to make sure that they're all equal to each other so that we have a valid palindrome. So we're going to need to have and calculate a midpoint of some sort. Okay. So we're going to do the following. We're going to say, well, for I, which we're going to call that as index in range, starting at 0, and we're going to go up to our midpoint. Plus, we're going to say, oh, we don't need to. Just do that. Okay. All right. And every time we look at this I, we're going to say that what the left side of our string, because we have grabbed the very first value, is going to be, well, text at I. Okay. And then our right side is going to be very interesting because we can now grab the left side by following this negative indentation, right? So if I was trying to compare H with exclamation mark, I need to grab -1 by using some sort of an algorithm. All right, so we're going to say the following. We're going to say text at location negative times our I value, and then we're going to subtract 1. So if I is 0, right? So if I is 0, we're going to have -1. If I is 1, we're going to have -2, because we're going to multiply that by -1 and then subtract 1. We are going into the more negative side of things, and so on. So we get to grow in a way that we want to. Okay. So with that said, we're going to do the following now. I have the left side and the right side, and those heights have to be equal. I need to know that this H is equal to the value at -1. I need to know that this E value is equal to the value at -2. And if I get to this middle part, well, we don't need to do that anymore because we already compared and know that if they were equal, we know for sure it's a palindrome. All right. So if we're going to say, well, if left does not equal the right side, well, then we know it's not a palindrome. So we can break here to exit the loop and something, but we can actually also do a return false. Return in a loop works like a break where it will auto terminate the loop. All right. Okay. So anytime, as soon as we find a instance that we have a value of left and right not equaling to each other, we're going to return false. And if the for loop is finished, so end of for loop, well, then I can just return true because I can safely assume that all the characters are equal to each other from the left and the right, and either we left the middle alone, or when that, in a case of an even numbered or even length string, we compared the middle two most values, and we were able to say that either they were not equal to each other, so we got to return false, or we returned true. So this is the ends of is palindrome 2. Okay. All right, and in this case, we're gonna just test it with a bunch of testers. We're gonna say is palindrome. All right, test taco cat, comma, it's palindrome. Taco cat for 1 and 2. We're going to copy that over, and we're going to have taco dog and taco dog. And we're expecting to be true, true, false, false. So here we go. We have true, true, and false, false. So there you go. We had 2 solutions. One was a very simplistic solution where we just took advantage of slicing and doing our reversing a string, reversing a list slice that you can get used to. In this one here, you wanted to go a little more complex, where you wanted to go based on the midpoint of a string and then just compare the ends until you get to the middle. And as soon as you got to the middle, is either you got to return true or you got to return false. Okay. So what I want you to think about is, well, we wrote a lot of code. Which code would actually be more efficient to run and better in a scenario where you're checking a palindromic word? So think about that for the future. But regardless, thank you for watching and stay classy.